Today we are talking about custom resource definition. This thing, it will be strange at the beginning, but it will make sense after you see the demo that I have prepared. So, custom resource definitions are a way to extend Kubernetes API by defining your own custom resources. Think as a defining a new noun that Kubernetes understand. They allow you to create new kind of objects, just like built-in Kubernetes objects like pod deployment services, config map secrets, and anything else. Uh, the CRDs, the short of the custom resource definitions, define the schema, the structure of your custom resource, specifying the fields and their types. The CRDs are declarative, meaning that you define the desired state of your custom resource, and Kubernetes will take care of making it so. Imagine like adding a new type of recipe to a cookbook. The CRD is like the recipe template defining the ingredients and the steps requiring for that specific dish. Um, they are okay. Let me show you how custom resource definition looks like. Not this one. CD. DevOps tools. Azure. Source. Okay. We create a CRD.yaml file, and as everything, we start with API version.
Are you sharing the screen?
Am I?
Because I can see.
No. I am now. API extension.here's.io/v1 connects custom resource definition. Also has a metadata, with name. Usually it's used for creating databases. Example.com, spec, group. Okay, this looks like a custom resource definition where you see that you set up the version, which version it is, if you have a storage, if it has services or not. Then you set up different properties with the types. You have to tell what type it is. Object, usually object means that is either a map or a list. The size, if it's the size, if it's expecting integer or float. Then if your storage class, usually this is one string, and it also has the type boolean for some properties like true, false, stuff like that. You can set it up with the names and the kinds, and this CRD defines a database resource within the example.com API group. It specifies the spec with the desired states and the statuses. Uh, the custom resource definitions usually doesn't take any space in the Kubernetes cluster. It's just something that is stored in the database. That you create a custom resource, and the custom resources are actually the instances of the custom resource definition defined by the CRD. They are like specific dishes made using the recipe template of the CRD. The custom resource contains the actual data that conforms to the schema defined in the CRD. And let's see how CR. I know, as I said, this looks complicated, but it is actually very simple once you get can open somehow a new page. As you can see, the API version is what you have set on the group, and version in the API. And so this compose API version. Then we have the kind, which is the database. It's configured in here. And we have the metadata name. As you can see, it is the scope is namespace. That means that the custom resource it has to run into a specific namespace. Usually, the CRDs are not namespace. Therefore, if you load this CRD into a Kubernetes cluster, and we type kubectl get CRDs, we will get its name but without being limited to a namespace. It is cluster-wide. And now we type the size. We know we have the size in here. It is expecting an integer. And the storage class, which is standard. And because we configured into the properties that we only require the size and the storage class, this is everything that we need in here. And this is how a cluster resource looks like. Now, I added in here in the course also another type. It's the operator, which basically are the CRD and cluster resources. And operators are software extensions to Kubernetes that automate the management of application and services. They use the CRDs and CR to manage the life cycle of a complex applications. The operators implement control loop pattern continuously observing and the desired state of the custom resource and reconciling it with the actual state. They handle tasks like provisioning, scaling, upgrading, backing up applications. So let me show you this one. Let's see if you can. Okay. I just let's get clusters. We don't have any clusters. Get cluster config and okay. Has to be lowercase. Let's wait for the cursor to start and get into the ready state. Export to config. Okay. Okay. And let me show you pro.run. We will export it, look into this Crow Kubernetes Resource Orchestrator. It is a very new project. It is at the version 0.2.1. It was initially created by AWS, but then Google Cloud and Azure jumped on the project, so it is developed by the three largest cloud providers, and I actually like it a lot. And to get to install it, we go to the documentation and we just copy a few comments and run it. It will, okay, they did not change anything. We install the helm chart, HTTL API resources, and as you can see, this scroll acts as a CRD. It has added the it has expanded the Kubernetes API with the resource graph definition, kind prototron slash v1 alpha 1 version, and this is what we need to look at into the in the kind. And this is the namespace, so you can see it, not namespace. So if we list the CRDs, we can see that the custom resource definition.crow.run is here. Now, what the heck? Okay, so for this project, we are going to use yet another project, and this is called Cloud Native PostgreSQL. And we go to the documentation and we go to the latest and we copy this. And this will install the Cloud Native PostgreSQL operator. And you see it will deploy a lot of custom resource definitions, some service accounts, some cluster roles, cluster role binding, config maps, kubectl get, kubectl get, port kind of CMPG, and the CMPG controller operator is actually already running. So now it starts the fun part. How should I do it? Okay, this is how in here, just to give you some short description, I am planning to deploy Drupal with PostgreSQL database. So I created the resource group definition, which will be the custom resource for it, and everything. The only thing that is not, you will not see it as, will not look as something you know, is this part until here. So it requires, as usual, API version, which is the crow.run view on alpha 1, the kind, which is the resource graph definition, the metadata, we give it a name. This will be called Drupal operator. And then we set a schema, spec schema. And in the schema, we configure, okay, we want the API version, we want alpha 1. We are setting the kind Drupal. And then we are setting some specification. I want the name to have the type, the string type, the image also be the string type, but I set the default as the Drupal image. The tag, it will be a string, then PG pass, PG user, PG subpass, this is a super user pass, and PG database, it's all string. And then I set some conditions for the status of the custom resource, which how to check it. So it's I tell, okay, look at the condition with the type and the status, and both has to be string. And now we are setting up the resources. So we start with the resources with the ID, and we type an identifier for these resources with the template. And in here, from here, it is a plain manifest file. Only thing that changes is that instead of having hard-coded names in here, I'm setting it as a variable to that would take the information from these, like a schema spec name. It's here, schema spec name, schema spec pgdb, schema spec pgdb, pg user. This is probably you don't know because this is the custom. It generates the custom resource for the cloud native Postgres. Where I also set up some database. I set up the owner of the database. I set up some secret where to store the credentials, where to store the super user credentials. Then this is a persistent volume claim. It should be more. It's easy. I'm setting up some volume claims for modules, profiles, themes, and size. This is a requirement for Drupal. It has to have persistent volumes for this for folders. Then we have a deployment, which is again, it's just a simple deployment with some variables instead of hard-coded names, hard-coded labels. Then the volumes, again, specific to the PVC that we have created. Container name, container image, as you can see, it has the schema spec image and schema spec tag. Listening on port 80, and we have set some liveness port. I did not show you the liveness and readiness probes, right?
Right.
Basically, in deployment or any workgroup, you can set up a liveness probe and the readiness probe that Kubernetes will be using to check if the pod is ready to get to handle requests or it is alive. First, if it's alive, and then if it's ready. If the liveness and readiness probe fails, then the Kubernetes will not send requests to that probe. Now, here I encountered some bugs in Crow, but I have talked with the developers and they are working to fix it while as you know, when we load the secret into the Kubernetes, if we use string data, then the Kubernetes will read the values of the variables and encode it with base64. So Crow is, since it's checking the values of the variables, it cannot reconcile because what it sees in the Kubernetes is different from what we are configuring in the CRDs or in the custom resources. So this is something that they are working on. As a workaround is we run it like this first, and once the secrets are created, we are going to comment out the values, the variables, and load the CRD again, and then it should move on. So yeah, that is a secret. And then we have a service. I was using a cluster IP. It can be load port, it can be load balancer. I did not have the time to play with the load balancer to see if it's running or not. So I just used cluster IP, and we're going to use a port forward to test it. Okay, let's save it. API resources. As you can see, these are all the API resources that currently this cluster has. We added the Chrome one and then added these for the Postgres, cloud native Postgres database. And we are going to apply, yeah, with the -f. And this is the custom resource definition. WPress was created. Now let's cube get resource graph definitions. We can see that there is something in here. But I did not save it. So let's delete it. To graph. Okay, was deleted and let's see. Qctl apply. Oh, PPPG. This is the wrong one. CTL get resource group definition. Okay, this is better. Drupal operator. API version v1 alpha 1, kind of Drupal, and is active and it was deployed 11 seconds ago. Now let's see so this is the custom resource. As I told you, API version, it requires this crawl.run, so probably there is another thing to fix for the developers. With alpha 1, kind Drupal, as you can see here, I use metadata minus name so test name. I use PG test and I set up the Postgres user, the Postgres pass, the Postgres super user, super pass. The super user is hard coded to Postgres. Then the Postgres database and we use the tag that is latest. As you can see, I did not set up the image because I will be using the default image that is configured in the custom resource definition. And if we don't want to change the image, then it will use the default value. You don't have to mention it into the CRD. And for the sake of making things interesting, let's create a namespace. Gives it minus else, apply minus test dot YAML prod. And gives it get Drupal minus prod. And you can see it was created and the state is in progress. And it is nothing, it is still in works. kubectl get secret minus prod. As you see, the first secret was created. So we're going to edit this, go to and we are going to command this to length up and apply it again. kubectl get is still active. Okay. kubectl get secret minus and port. It has created also the second secret. So I will edit it again. We will comment out and apply it. kubectl get port minus and prod. And let's watch it. So as you can see, it started to creating the Postgres database. Uh, it creates three workers on the Postgres. It also deployed Drupal. Now the databases are up. It has run some joins and in it to create the database and join the cluster to the nodes into the Postgres database. And the Drupal is working as well. So kubectl get pod and pod. Everything, as you can see, everything is up and running. Now let's exec into the pod. PG test run. There's the bash. This is the databases. As you can see, the database user, the Drupal database was created. Also has the Drupal user was created. So everything looks good from the database point of view. Uh, Cube, kubectl get svc minus temp prod. Kubectl. Oh, okay. As you can see, the Postgres database is create three services. I honestly don't know what is the difference between R and RO. I know this is read only, but this is, and there is one service that is read write. This is the one that we will be using it to set up the Drupal, kubectl, minus m prod, forward, service slash pg test service. Okay, and now let's check our localhost 8080. And as you can see, everything is working. We select English. Now, just a heads up, it will fail at one point because apparently there is something that is not working in Drupal, some Ajax stuff, and I don't know how to fix it. So it needs some files in it. kubectl and roll get pods. kubectl and prod accept me pod pg test. I need to add to copy some files into the proper folder so that it will move on. find slash in or no, therefore dot testing dot php. Oops. Okay. Let's see if I can make it here. Oh, size default. As you can see, these four folders mounts are actually mounted from the PVC. Okay, that's 6 feet, and let's do the port forward again. Okay, to move on, database name is Drupal, Drupal user, database password. UCC, I guess, SVC minus M prod. I42 is the default port of the Postgres. As you can see, it is running on that port. Save and continue. Okay, this is the error that I got until now, but I don't know how to fix it. But anyways, you'll see that it's an easy way to deploy. For example, you have a complex application with multiple microservices. You can configure a template in a format of the CRD, and then you can quickly deploy in development, production, staging. If you want to do tests, you just deploy a test environment very quickly, run some scripts to load the SQL files, and have the environment running, run the test, and then decommission it. And it's very simple to decommission it. kubectl get Drupals minus and prod. As you can see, its status is active, it's synced, everything is up and running. kubectl delete Drupals so test minus and prod. It will take some time. Wait a bit more. kubectl minus and prod get post. As you can see, the Drupal was already decommissioned. Now it also decommissioned the Postgres, and it has deleted everything. Everything is clean as it was before. Any questions?
I have a question. When you created the secrets, I saw that you commented out and reapplied again. What was the purpose? Because I didn't catch it.
As I told you, the secrets doesn't recognize yet the values with what it was deployed to the Kubernetes. So I commented out the variables so that it does not check for the values of the variables, but only for the existing of the secret itself.
Okay.
That is why I reapplied it. And once I reapplied it, it checked again. And they said that, okay, the secret exists, move on to the next phase.
Okay, okay.
This is a bug. They know about it. They are working on it. So probably in the next version or next two versions, very soon will be fixed. We will not have to do that for a very long time. As I said, it's a very young project. First time I heard about it, it was about a month ago, and at that time it was version 0.1, not even 0.2. Any other questions? I know. So this is the way databases can be used in production, and this CNPG is for the PostgreSQL. It is very good and it is very stable. There is one operator for MySQL and MongoDB created by Percona. Are you familiar with Percona?
No.
Basically, I don't know if you know the history when MySQL was bought. Actually, no. Oracle took MySQL under his flag. Part of the developers ported from it because they didn't want to work with Oracle. So they created the MariaDB. And another part of the developers, they created the Percona. And The Percona, I like it because they have created this read-write cluster or a multi-master cluster called Percona ExtraDB. It is very good, especially if you want to have a database across multiple regions. You can do that because it will sync the different nodes between each other. Of course, that adds a level of slowness because it doesn't confirm the query until everything is synced across all the nodes. So you have to have a very good connectivity between the nodes in order to make it work fast. But yeah, this is on short everything that I had for today. It is better than Helm deployment because the operator, what it does, if something gets screwed, for example, one node goes down or someone deletes one of the shards of the database, the operator will make sure that it will recreate it and it will be fully synced by across all the databases, all the nodes. The Helm chart doesn't do that. The Helm chart, you deployed it, and then it doesn't care if you screwed it up, you deleted one node or one shard. It will not try to recreate it until you run again Helm update with the same values. But the operator will always check and make sure that the desired state is active and is reached and is reconciled. Any other questions? Okay, I am not asking for a homework, but if you want to play with this crow, I would recommend it. I know it can be a bit of a bit more a lot complicated. And first hand when I tried to work, I tried to work with WordPress. I just took a Helm chart and converted it to a manifest and wanted to try to do that. But since that WordPress was created, it was expecting to work from a Helm chart, it just didn't want it to work. So I decided, okay, let's drop it and I will be using a Drupal and that worked without any problem. So if you have anything in mind, I would recommend to do it. If you have questions, you can ask questions. I'm here to answer. I will put these two manifests on my repository today so that I will not forget it. And yeah, that's it from my side.
Thank you.
Okay. Yeah, stop sharing the screen, saving the recording.